All right. Welcome to everybody out there. This is Amateur Radio Roundtable, a show about ham radio. And if you're out there listening tonight on WBCQ, famous international shortwave station, we'd like to welcome you and we'd like to hear from you. If you're out there listening on shortwave, send us an email to tom at w5kub.com. And let us know where you are and give us a signal report, and we'll get you a QSL card from WBCQ. Also, if you will, hit the subscribe button on the video. This show is actually a video show on YouTube. So let me just mention to you listeners out there on shortwave, if you can, if you have internet, you can join us on Tuesday nights at 8 p.m. Central Time. Just go to w5kub.com and you can join the show, the video show, and you can join in the chat room and actually communicate with us. Please hit the subscribe button on the video. It helps us out greatly to rank our program and get more viewers. So we appreciate it if you do that. Just wonder if there are any new people tonight, first-timers tonight in our chat room. If this is the first time for you to join our show, say hello in the chat room there. We'd like to see who you are and let us know where you are. And love to hear from you there. Just heard from Bill Brown today. He's up helping clean out a lot of, he's cleaning out the barn or some of his dad's old stuff up there, and he had an accident, I think, at Walmart. I think they pushed some pallets or something over on him, and I think it may have fractured his foot. So he's going to see a foot doctor today, and we'll find out how Bill's doing here. Haven't heard from Katie tonight. Not sure where she is, but she'll probably be back with us next week for sure. Let's jump around the room here real quick. Looks like Glenn is up. Glenn, how you doing, man?
Oh, hanging in there. Just talking, before the show that there's that Ham Fest up in Truman, Arkansas, about an hour northwest of here, this weekend. So I'm going to be able to head up there and see if I can't sell some stuff and buy some stuff.
Okay, well, cool. That Hamfest is over in Northeast Arkansas. That's my home. That's where I was born and raised, over in Northeast Arkansas, a little town over there called Wilson, Arkansas. It's probably no more than 20 miles from Truman, I'm guessing. I don't know. I have to look at the map, but I may go up to my hometown this weekend. I might swing by there at the Hamfest and see what's going on there. So we might see you there. I don't know, man. But
well, like I said, I need to get out of the house.
Yeah.
This would be something fun to do. So,
well, talking about Hamfest real quick, Nearfest in Deerfield, New Hampshire, is this weekend, Friday and Saturday. So there you go, Nearfest, Deerfield, New Hampshire, Friday and Saturday. If you're up in that area, drop by there and check it out. All right. Okay. Let's jump over to Allan. Hey, Allan, what are you doing tonight, man?
Yeah, good evening. Good to see everybody. Sorry I've been absent the last couple of weeks. Just the work's been keeping me really busy. But real good. Thanks for picking up the note there on Nearfest. It's Deerfield, New Hampshire. Unfortunately, that's a good 4.5 hours for me. So I'm probably not going to be going up to that, but pretty cool that it's a 2-day thing, Friday and Saturday. So if you're anywhere in the area, it's one of the larger ham fests here in the Northeast. So sounds like it would be a good time. Weather, I think Friday's supposed to be good. Saturday is a little bit iffy, but at least here in New Jersey. But we'll see what happens. But should have a good show tonight. I do have a little bit of a topic for tonight. Thought we'd chat a little bit about the basics of super heterodyne receivers. So not going into it in too much depth, but at least to give you enough of a background to understand how they work. So that'll be fun.
Okay, very good. Looking forward to it. And And I've got a little short video here on a tower that just folds up or rolls up. Glenn, I think you know what I'm talking about, from the Memphis Homeland Security Tower. Do you remember ever seeing? Well, Glenn, you remember seeing that tower in Memphis?
I never saw it, but I saw your video of it. I want one.
All right. Well, I've got it here, and we're going to talk about it here. Okay. Well, hey, you want to welcome Jeff there, KM4QBC, in the chat room area. He is one of the Dead Possums. And guys, if you want to hear some good music, check out our YouTube channel. He and his son opened up the show one night, playing and singing on our front porch over in North Carolina. So I'm glad Jeff's with us. Hey, Jeff, we built Jeff a 40-meter antenna when I was over there a couple weeks ago. Jeff, did you ever get that antenna in the air yet? Are you on 40 meters? Just let us know. Well, all right. Let's see. I think we ought to just jump right into the show tonight and just talk about it. Let's get Allan in here first, and let's get started with super heterodynes. I think he's going to talk about super het receivers. So, Allan, you wanna go ahead and get started?
Sure. Yeah. So, back in the very, very early days of radio, I guess a lot of rigs were TRF radios, or tuned RF stages, where when you turned the dial to tune in a station, you're actually tuning a bandpass filter to select the particular station that you wanted to go tune to. And when you start getting over a wide frequency band or want to do multibands, that becomes extraordinarily difficult to do. So actually, Edwin Armstrong in 1918 actually invented the super heterodyne concept for receivers, and of course the same works in transmitters as well. So I thought I'd just kind of review what that architecture looks like. So let me start up with a screen share here, if I could find the right one, and let me know if you can see that.
We can.
So we can on the outgoing feed.
Let me kind of make things look a little better from this side.
Okay.
Get those pictures out of the way. There we go. That'll help.
There you go. Okay. Yeah. So super heterodyne receivers. Really, there's two key elements that make a super het work. Okay. As a frequency conversion, which is going to have to do with mixing and mixers. So we'll talk a little bit about that, and filtering. And that really has all to do with processing in the IF. So maybe a couple of different definitions here. Where does the name super heterodyne come from? Well, the heterodyne is a term, when you beat two signals against each other and mix two signals against each other, you create things like sum and difference frequencies and things like that. And that's a typical heterodyne process. If you've ever listened to, tuned off of an AM station when listening to a single sideband, you've heard the beat note of the carrier. That's due to the heterodyne of the carrier against the BFO, and it's also typically how we listen to CW, is by heterodyning. Heterodyning for audio results like that is typically just called a heterodyne operation. Super heterodyne means the word super was added there for when you're doing this heterodyne operation or this mixing operation at ultrasonic or above audio frequencies where you can't hear it. So that's the only thing that's super about super heterodyne is the fact that you're not at audio frequencies, you're at some other higher frequency. So we're going to talk a bit about mixers first, because that's kind of the key in how super hets work. So we'll just talk about in general what mixers do, and then we'll talk a little bit about the job that the IF does, IF filtering. IF, if you're not familiar with that abbreviation, stands for intermediate frequency, and we'll talk about what we mean by that shortly. But it really is an intermediate stage where we're converting signals into an intermediate stage there, and or maybe sometimes more than one. And that's called the IF, or intermediate frequency stage. So when we start talking about the block diagram, it'll become a little bit clearer. So let's start off with just a little bit of an overview of mixers, okay? And, a mixer, I'm just drawing kind of a very generic diagram here. There's lots of different forms of mixers. Kind of a classic, diode ring, double balance mixer is what most of us, if we built radios and things like that, have probably built one. Or if you've ever, built a radio device using like an NE602 or 612, they use a different type of a mixer called a Gilbert cell. It's a Gilbert cell multiplier, but effectively does a mixer. So really what a mixer does is it takes two inputs, one that we'll call a local oscillator, okay, that we're going to generate inside the receiver, basically an oscillator that's inside the receiver, and then our input frequency coming effectively from the front end of the radio, from the antenna. Okay, but let's just call it generically frequency in, or F in for now, and we've got our FLO, the frequency of the LO. Both those two signals are going into the mixer, and that's going to produce an output. Okay, and what is that output going to consist of? Well, that output actually consists of a number of components. Even if the local oscillator is one frequency and I'm putting a single frequency into F in, we're going to get multiple frequencies out of the output. We're going to get an output that is the sum of the input frequency and the local oscillator frequency. And we're also going to get the difference between those two, and it could be frequency in minus the frequency of the LO, or frequency of the LO minus the frequency in, whichever one is higher. Okay, and that actually is a little bit of a property that can come to bite us a little bit later, so we'll talk about that here in a moment. So a way to look at this graphically is to say, okay, I've got an input frequency. Let's picture this as a spectrum analyzer axis, or a band scope axis, where we're looking at frequency across the x-axis here, amplitude in this direction. So I've got a signal sitting at F in, I've got a signal sitting at my local oscillator frequency. So if I look at the sum of those two, I get an output on F out here at a frequency equal to the sum of those frequencies. And I'll also get an output here at the difference of those frequencies, FLO minus FLN, or in this case, since FLO is higher than that. So we've converted, this input signal that we want to receive to one of two places in the frequency spectrum. So what we'll wind up doing is essentially using a filter to select one of them and not the other. Okay. But as I mentioned, this little property of converting the difference frequency can come back to bite us in the form of something called an image. So let's say the input to this mixer is coming from an antenna, and that antenna is picking up signals all across the frequency band, right? So it could be the signal that you actually want to hear, but there could be a signal that's spaced just appropriately far enough away on the other side of the LO, okay? So that we would call an image frequency. When we take the difference between F image and FLO, guess what? That can land right on top of the product that we want. Okay, so that's called basically converting an image down. So we're going to essentially convert two frequencies on either side of the local oscillator into our desired frequency bin. All right. So this is typically why on the front end of a receiver you've got a low pass filter, because what you want to do is filter away the signal that would normally get converted into the image, so it never sees the front end of the mixer. Okay, so and this is part of the reason why, topic for a next level class of why we do things like double conversion or triple conversion receivers, is to make it easier to deal with rejecting the image and keeping it out of our signal processing. But this property of creating sum and difference frequencies is really the key to operating to what happens in a super heterodyne receiver, is that we're just doing this frequency conversion. It's like, all right, why do I want to do that? Well, if we take a look at the basic architecture of a super het receiver, it becomes a bit clearer. Okay, so here's our basic front end architecture of a super het receiver. We've got our antenna going into some front end circuitry, and that could contain an LNA, like a preamp, to do some amplification of low level signals. It might include a front end attenuator, or both of those that you could switch in or out as you need them to kind of process the signal before it gets to the mixer. It may include some front end limiting to protect the mixer from high input signals. It could potentially include some filtering for things like image rejection and things like that. And also may have a variable gain amplifier that is part of the AGC circuit. So all of these things could be right at the front end, processing the raw RF as it comes in from the antenna. Then we get in kind of to the superhead stage. We're passing all of those frequencies that are coming into the antenna right into the input of the mixer. The mixer has got a local oscillator, and when you're tuning the VFO on your radio and dialing up and down, you're not tuning a filter. You're tuning the frequency of this local oscillator. And by tuning the frequency of the local oscillator, you're basically sliding around all of the signals that are going to land in the IF. So after the mixer, we have this thing called the IF filter. Okay. And the IF filter is typically a bandpass filter. On many receivers, that's got an adjustable bandwidth. In the kind of the simplest sense, when you dial in like a CW filter that's a narrow filter, or a single sideband filter that's a wider filter, this is essentially where it is. Oftentimes it might be down into a second or third conversion stage, but conceptually this is where this is. So the idea here is that we've got a filter and an amplifier that only have to be set up and optimized to operate at one frequency. And that one frequency is what's called the intermediate frequency, or the IF. In many shortwave radios, like single conversion radios, like the old realistic DX160 or something like that, this IF is typically at 455 kilohertz. So this filter is a bandpass filter centered at 455 kilohertz. So its skirts can be optimized and the amplifier can be designed just to work perfectly well at 455 kilohertz. So the whole idea is that we're using the local oscillator to convert the frequency of interest of the massive amount of frequencies coming into the front end, to convert that one frequency that we want to make it land inside the 455 kilohertz IF. And then we can amplify it, and then from there, that signal goes off to the demodulation stages, whether it's just an amplitude detector or maybe a product detector or a BFO for listening to single sideband, or a CW, or maybe an FM ratio detector for FM or something like that. But the whole idea is that all of the critical processing in terms of filtering to get good selectivity and things like that only has to be set up and run at one frequency. And we're using the mixer stage to put the signal of interest into that frequency bin. So we can look at that graphically and say, okay, let's say I've got a band of frequencies here. Again, this is a frequency band here, and maybe I'm showing 3 stations here, right? One here, one here, and one here. That's all coming into the receiver front end. And then we've got our local oscillator that we can tune around back and forth. Okay, and remember, in most cases, we're looking at the difference frequency. So we'll take the difference frequency of whatever's coming in here, or effectively all of this. Okay, so we take the FLO minus all of this. So that whole frequency spectrum gets converted down, and these signals can effectively be slid back and forth in frequency by simply changing the local oscillator frequency. So as we tune the local oscillator up, we can slide all these things up. We tune the local oscillator down, we slide all these things down. And the whole idea is we're sliding these signals back and forth until the one that we were interested in falls right inside the IF filter. So it's going to let that signal pass through, and then the signals that are outside the bandpass of that IF filter get blocked. So at the end of at the IF output, we're only selecting that one particular signal. So by simply, again, tuning the local oscillator up and down, we can slide this whole spectrum of signals. So we put the signal of interest right in that filter, and then send that off to go be demodulated and analyzed, or whatever it is that you're doing. And of course, the same process works in reverse, and superhead stages are typically used in transmitters as well. But this is essentially what that process is. Now, in most cases, most of our ham radio transceivers are typically going to be double or even triple conversion devices, not single conversion like I've described here. And all that means is that we're going to have a couple of stages of this. We're going to have, a mixer, local oscillator, and some IF filtering at one frequency, and that might be followed up by another mixer to convert down into a different IF. And there's reasons for doing that. Because generally the higher the IF frequency that you have, the easier it is to deal with things like these images, right? Because they'll be further and further away and easier to filter out. Okay, but it also makes it harder to make a very selective filter to reject close-in adjacent signals. That's easier to do at lower IF frequencies. So oftentimes a real superhead is going to have at least maybe a double conversion. So that first IF is going to be a wide IF to give you good image rejection because the images will be further spaced away from the signals of interest. And then mixing down into a lower IF frequencies where it's easier to make real steep, narrow filters to get good selectivity from station to station. So that's kind of the fundamentals of what an IF or excuse me, a superhet receiver is. I'm just going to take a quick look in the chat here to see if there was any questions that popped up here, but I don't know if I see anything here. Oh, I do see one from Brett here. I'm working backwards here. So Brett is asking if I could explain what the IF shift knob on most rigs does and where do roofing filters fit. Great questions. Okay. So if we scoot up here, typically when you have an IF shift, it's typically going to happen inside like a double conversion receiver. And the idea is that we're not really adjusting, again, the IF filter position, but that's how it's acting. The IF shift it's going to behave as if we're moving the IF filter back and forth so we can reject one side or the other. But the reality is that we're actually adjusting the local oscillators on previous stages to slide the signal around so that maybe in one filter it cuts one side, the other filter cuts the other side. So by making fine adjustments to the various local oscillators, we can convert the signal of interest into one side or the other of the IF filter, and then do frequency correction on the next stage to kind of restore back, to essentially zero beat the signal again, but take advantage of some of the skirts of the filter to reject something that's very close. Roofing filters, again, you'll typically find in multi-conversion receivers, like a double or triple conversion stage. And oftentimes in a triple conversion stage, that roofing filter is typically something that's going to be right after the first mixer. Because the first mixer is converting basically everything down into usually a fairly high IF. And a roofing filter can be used there to do some pre-selection to reject, nearby strong signals so that they don't hit the next stage and cause any overload. But that's typically after the very first stage of mixing and conversion inside a receiver. So in a sense, the roofing filter term could be applied to a filter that's even before the first mixer, but I think in most instances of our ham radio transceivers, it's after the first conversion stage. So let's see if there's any other questions here. I don't think I see any.
Yeah, there was one that started into a discussion now, and that's what was the reason the 455 kilohertz was chosen as the IF?
It's a good question, and I think it really had to do with broadcast AM. Because if you look at the broadcast AM band, in the U.S. here, 540 kilohertz to about 1.8 megahertz. The 455 kilohertz is just below that band. Okay, so you could do essentially a high side conversion, have your LO sitting just on the high side of the AM broadcast band, and so any LO leakage would not interfere with the AM broadcast, and then the IF would be at 455 kilohertz, which is below the AM broadcast band, or just below it. I think that's probably the root of some of it, but I'm sure there are people out there that know better than me. But that logically, that kind of tells me that's at least a piece of why that happens. Again, I'm sure somebody knows better than me, and it looks like it's like N7XGR says that some manufacturers use 450 or 460 to get around the RCA patent. Okay, so I guess RCA.
So there may have been a patent involved that may force the standard.
Yep, yeah, and that could very well be. I mean, there's a couple of kind of standard IFs, right? Typically, that the lowest frequency IF in many receivers is 455. in some receivers like my old Trait 2B, that final IF is like at 50 kilohertz. Okay. But then also like in many radios, especially in even broadcast FM radios, there's a double conversion, and the intermediate stage is typically a 10.8 megahertz IF.
Yeah, I was going to say there's typically a 10 to 11 megahertz IF for a lot of rigs.
Yeah. So, and again, there's generally some good reasons to do a conversion into a high frequency IF to start with, because it really helps the job with image rejection and things like that. Most test equipment like spectrum analyzers and things like that do that. But each time you add a conversion stage, you also potentially add noise and other things like that. So there's reason not to go too far with it. Okay. And of course, all these rules are getting broken, in the days now of, things like software-defined radios, where you sample and get to bits as quickly as possible and do everything else in digital signal processing, right? So you might actually, you may have one mixer that converts down into some IF, and you just convert there right to digital, and everything else is just done in software or firmware. So, it's the rules are kind of being rewritten a little bit with a lot of the software-defined type work.
Yeah, they're basically turning it into a transverter rather than a selective receiver. Just convert the whole band and slice out what you want.
Yeah.
Over the years, back in the olden days, we used a lot of converters to get on the bands we wanted to get on. It was common if you wanted to get on 6 meters. If you had a 10-meter receiver, you just mix a couple signals. Just the same thing as what you're talking about there, Allan. And
yeah, I've even heard. I mean, you've also probably did the same trick that I did as a kid. If you want to decode some or to listen to and demodulate some single sideband signals, and all you had was a couple of AM receivers. You oftentimes could hold one next to the other and turn one of them around a little bit, and you had enough LO leakage from one of them to essentially inject the carrier into the other, so that you could convert the single sideband.
Yeah. I mean, it's been used many ways, I guess, since the beginning of time. My first novice contact was made up in my little town. I didn't even know there was another ham in town. I used a 9-transistor. My receiver was a 9-transistor AM shortwave. Mm-hmm. Had a pull-up antenna on it, and AM only. And I think the shortwave band went from something like 2 up to, I don't know, maybe 30, maybe not that much. But the 80-meter band was about a quarter of an inch long.
Yeah.
And the novice band, of course, was about the size of the slice of the needle that's across the band there, Right. And it was AM. And I had a signal generator, and I beated that signal generator against that transistor AM radio, and I could hear the CW.
Yeah.
And that was my very first contact. It shook me up so bad. I don't even remember what the guy said. I copied very little. But we used a signal generator and beat that against an old transistor radio. And after that, I knew I got to get me a better receiver.
Okay.
Yeah. All right. Well, that's interesting. Great stuff there. I put your picture back on there. I found out on Zoom here I'm able to go from your presentation to your picture, so I brought you back up there.
Very good.
All right.
I'm going to probably at some point, I've got the luxury, obviously, working for Tektronix. I've got one of the oscilloscopes I have here is an 8-channel scope that has got a digital down converter behind every channel. So I can essentially have a spectrum analyzer on every channel. So what I'm going to do is I'm going to yank my DX160 off the shelf here, bring it down there, and put a probe on the RF input, put a probe at the mixer input, put a probe on the LO, put a probe on the mixer output, and a probe at the output of the IF filter, and show how everything moves around when you're tuning it around. So
that's cool.
Looking forward to playing with that.
Maybe you can show that to us one night once you get it all set up and figured out.
Yeah, I'll probably make a video of that, and that'll go on the channel for a we'll show it here as well.
Yeah,
Okay.
that'd be cool.
Well, very good. All right. Well, let's stand by just a second. We'll be right back with everybody. And first, we'll do this. Contest remote. ICOM has the perfect base station ready for action. The IC9700, the IC7610, and the IC7300 transceivers are top of the line and are the first choice for contesters across the globe. Robust base stations like these cut through pileups, letting you work the bands and record those contacts. Stay connected and keep your competitive contesting edge with ICOM. Heard it, worked it, logged it. Create your own band openings with the 9700. This transceiver brings direct sampling to the UHF-VHF weak signal world. It's loaded with innovative features that are sure to keep you busy. It has faster processors, higher input gain, higher display resolution, and a cleaner signal. Check out the large touchscreen, the Spectrum Scope waterfall, smooth satellite operation with 99 channels, and it has full duplex operation in satellite mode. The IC7610 is the SDR that every ham wants. This is a high-performance SDR, and it can pick out the faintest signals even in the presence of stronger adjacent signals. The 7610 is a direct sampling, software-defined radio that will change the world's definition of an SDR transceiver. It has RF direct sampling and independent dual receivers. The IC7300 changed the way entry-level HF is designed. Top-performance, innovative HS transceiver with a compact design will far exceed your expectations. It has RF direct sampling, 15 discrete bandpass filters, a large touchscreen, and real-time spectrum scope. Visit www.icomamerica.com/amateur for more information on ICOM radios.
LDG Electronics provides state-of-the-art antenna tuners for every amateur need, from QRP to QRO, fixed station, portable and remote, matching your radio to your antenna using our lightning-fast proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. Our focus is on anticipating and meeting our customers' needs and providing them with world-class support as they install and use our products. All LDG products carry a full 2-year warranty that is fully transferable when you sell it, with no paperwork required. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
Yeah, with the new job.
All right.
Turned into my bedtime.
We're back, guys, and that was a great segment that we just had on super hits. Looking forward to your next segment here. Let me make this announcement again really quick. First of all, do we have anybody new tonight that's tuned into the show? Tell us in the chat room if you're new and first time here. We'd love to hear from you. And again, I want to welcome everybody out there on International Shortwave on WBCQ. Send us an email to tom@w5kub.com and let us know where you are. Love to hear from you. Hit the subscribe button. Please hit the subscribe button there on our video. You know, we talked about a few weeks ago, I talked about a tower that Memphis has here, and they use it on field day. And I didn't explain it very well, but this tower, you know how you have tower sections and you see these 10-foot sections of tower stacked up, and when you put the tower up, you need a gen pole and all that. I'm going to show you a tower that's actually built as it goes up. A machine builds the tower as it goes up. And as it comes down, it's taken apart, and it's stored in three little compartments. You got 3 sides of the tower, and it takes a little 2-foot piece off each of the 3 sides and stores it. And then when you go up with it, the machine grabs these pieces, it puts the tower together, it pushes it up, it grabs a couple more pieces, puts it together, it pushes the tower up. So I want you to see this, and this is going to be an interesting, I'm not sure how good the video turned out, but this is the one I was able to find today. And if you watch closely and you heard how I describe it, you might be able to see there. So let me see if I can get this running here.
Yeah, if I remember correctly, that was the weekend that we had the deluge over Field Day.
Yeah. Furnished by Homeland Security here in Memphis. Let's go over here and take a look at it real quick. This is a very interesting tower. They're not operating right now, but I think I have some video that maybe shows you how it operates. But this tower actually folds up and rolls up. And if you look right here closely, you see the little square right there? Those are tower sections. If you look over there, there's the other side of the tower sections. All right, they're going to take it up. Let's see what happens. All right, coming down. Well, let me see what's going on here. Oh man, is that actually folding up the tower right there?
Three Baylor segments. There's 3 Baylor segments, and this thing will go 80 foot in height. We're coming down now. The tower will support 2,000 pounds on the top and was originally designed to be an air drone launch platform for the military.
I've never seen a tower fold up like this. It's like it's folding up in about 2 foot squares.
Going back up. We're actually running at 60 feet today, so we have to guide it. Up to 40 miles an hour.
This is amazing. I've never seen a tower fold up like that. It's like putting it into a box. Reels of coax that will feed the antenna, or feed the antennas on top of the tower. You might can see them. I can't see the sun's mines, but you just connect your radio right to the end of the coax there, and I think you have 100 feet on those reels. We've got some radios in that box right there. Here's another section where it pulls up the tower. Let's see if you can see it a little bit better. That's actually sides of the tower right there. You can see on the other side over there how it folds it up. It disassembles it. It disassembles it and it puts it into a little square box, and the whole tower comes down. That's kind of cool. All right, well, you got to see it. It's hard to visualize unless you really watch this thing, but it'll go up 80 feet in the air. It'll come down to nothing, and it just disassembles it, and it stacks each of the 3 sides. It just kind of stacks them in little piles there, and then as it goes up, it picks, the 3 sides, puts them together, and it goes up, and then it picks the 3 sides, and it goes up. So it's kind of neat. I'll try to get, maybe next time I get out here, I'll try to get us a better video of that and let you guys, maybe we'll try to demo it a little bit more and let you see
the camera like inside it there while it's unrolling it.
Yeah, if we could get the
come together, that'd be cool.
That might be a little dangerous sticking the camera in the middle there, though. I don't know how this thing works, man, but we'll try to get some better pictures here of it pretty soon.
Take one of those cameras that you had up in the high altitude balloon, leave it in
put
there.
a GoPro in the middle.
They go walk away. Right?
Yeah. I could probably set one in here before he turns it on for sure, and we could. That would probably be a very cool, a cool one here. Let's see what the chat room has to say about that. How they latch in place, man, I have no idea. My understanding is that was about 60 feet high. At 60 feet, they don't even have to guy it. I think when they go 80 feet, they say they guy it.
I'm going to have to be Googling that one later.
Yeah, I like the spools of coax, so it automatically fed the coax too. That was
spools of coax and spools of tower.
Yeah, spools of tower there. Yeah, that's it's really really interesting there. So we'll try to get more information on that. That was actually built for Homeland Security, and I don't think he was. I think on the video he may have said what it was for. I don't. What was it for?
a drone launching platform.
Oh, okay. I don't know. Yeah, it must be a big drone. I don't know. But of course, various different cities get this equipment from the government, and Memphis was lucky to have gotten that. That I don't know what to call it. Tower that
Well,
grows.
at some point, they're going to be surplus.
Yeah.
I'll take one.
All right. So, hey, we'll open the phone lines in just a few minutes, everybody, and we'll get some participation from everybody here. You may, if you've been following the Facebook group, we are about ready to launch W5KUB 100. That's the APRS call, W5KUB 100. And we think we can break the glass barrier with that. There's no balloon out there today that hams can fly in a float like we float them around the world. There's no balloon out there available, actually. You can't use a weather balloon. You cannot use a weather balloon for this purpose. And you're limited to what's on the market out there. So anyway, we've been looking for about a year to try to find something that will fly. There's our person right there I mentioned. So anyway, we wanted to see if we could break that 40,000 foot ceiling. And we just built this one up. We got some new material, and we think with the calculations that we did, it should fly at above 50,000. So I think we're going to be able to do it. And this is kind of what it looks like. That was it in the shop there as we were doing some pressure testing with it right there. So I've got a little video here too where we actually built that. I might put that on in a minute. We found this material in a sleeping bag. There's actually a emergency sleeping bag. It's where we found the material. Now, plastics and poly and none of that stuff will hold the pressure up there. This Mylar will do it. All the balloons that hams have been able to fly are much smaller than the SBS balloon, or you can pay about $170 for the SBS balloon. But this sleeping bag is almost the identical size of an SBS balloon, and it comes in at about 19 grams lighter. And our pressure testing showed it will hold the pressure, and it will fly at 45,000 feet. So now we have an option here where we can take $1.50 sleeping bag and fly it in place of a $170 SBS balloon. I've got a video
idea about the UV resistance of that material.
Well, the material is supposed to be UV resistant, but who knows how much. It is silver, it's reflective. Hey, it'll make a nice radar target for sure.
Yeah, right.
We won't have to put a radar target on this thing. So I've got I want to show you what we found out on the let me find it, sleeping bag right here. This is we took the sleeping bag up to destruction. Let me get the sleeping bag in here. We took the sleeping bag up to destruction. Now, we need about 7, this is a manometer, I've explained it before, but you measure pressure in inches of water. And whatever inch of water you see there, you have to double it, because you have to take both sides, the side that goes down and the side that goes up, and add them, or you just double it. So we're going to check here the pressure, and I want to show you what this material will do. 16 inches of water. When I built, whoa, look, you see where we are? We're going to pop this thing right here. In just a minute, we're going to pop it. We're up almost to 9 We're over 9. That's 18 inches of water. 9.5 will be 19 inches right there. Here we go. It's fixing to explode right here. There it goes. And we just had explosion. I guess you might have heard that. There we go. So it's like we popped it about. So we saw that that material will withstand 19 inches, about 19 inches of water pressure or water lift, which is about 5, according to the calculations, it's about 5 times the pressure that the balloon will be at altitude. And if you guys remember, when we built that poly balloon, we were trying to use netting. We had 2-inch and 1-inch netting around it to try to hold it together. And the pressure got so hard and so heavy in that balloon, it was actually popping the nylon. It was popping the nylon netting. So and that was at about 3 inches of water lift, whereas this material here alone went up to 19 inches, which is again very much higher. So.
That's pretty cool.
Yeah, so we found a material.
Did it fail on a seam, or did it fail in the middle of it somewhere?
Well, let's look at it right here, and we'll see. Actually, the sleeping bag came pre-taped, like a bag you get in, and it actually failed, I think, down that seam, not quite on the seam. I think what happened, it probably had a failure on the seam, and then it just split. So let me put it back on here. 17 inches, about 17. Let's see. I think this is, okay, here we go. Right. It basically split right along the splice. You can see the splice here down one side.
It looks like a giant Jiffy Pop.
Yeah, it kind of does. Yeah. So this tells me. So what we found out there, actually, the material, the Mylar material, will actually handle a lot of pressure. Where poly and other things, they just stretch. We can never find anything that would quit stretching. This will not stretch. And when we built that out of the poly one, if you remember that balloon, when we built one, it was almost 20 feet long, and it was like 12 feet tall. And what happened was it just kept stretching. It never stopped stretching. And it'll get to a point where it just stretches so much, it gets so thin, it will break. So this material will not stretch. The tape we're using is some special poly tape that once it goes on there, it will not come off. And I've got another quick video here. I'm going to show you. We built the W5 KUB 100 last night, and I'm pressure testing it today. And let me pull it up, and I'll show you kind of how we did it. Now, hey, the sleeping bag was already taped with that brown tape down the 2 edges and across the foot. So, and that tape held pretty good actually. We went up to about 19 inches of water. And that tape was only about 1 inch wide. What we put on the seams on the one we built last night is 3 inch wide. And we also put adhesive inside. Let me see if I can pull that up real quick. I'll try to fast forward here, but a lot of people are interested. They've been asking questions about this. The W5KB-100 balloon. The reason we call it 100, this is a special balloon. We're going for the gold. We're going to try to break the glass ceiling. As many of you know that have been following the balloons, the SBS balloon is about the only balloon that will go as high as 45,000 feet. We want to break that barrier. We've not been able to do it with any other materials up till this point. Been a lot of testing over the past year, and I think we found some things here that might be successful. First, I found a Mylar sleeping bag. This is the emergency sleeping bag. And actually, the sleeping bag is 82 inches in circumference it's 72 inches in circumference, and it is 84 inches long. That'll make a pretty decent sized balloon. In fact, that's pretty close to the SBS balloon. This weighs 80 grams. The SBS balloon weighs 109 grams. So the sleeping bag is very close to the size of SBS, so it's going to fly about the same height. Next I'm going to show you right here is I was able to purchase some sleeping blankets, emergency blankets, which were much larger. They're 144 inches wide, which gives us about 4 times the capacity of a SBS balloon. I'm just showing you the difference here right now. This is much lighter. Pressure testing has showed that this can stand tremendous pressure. And I'm just going to fast forward a little. I got some Mylar material. Here I ordered this new material here. This is Mylar material. And it is 72 inches one direction, but it's 142 inches in the other direction. So it's quite a bit larger than what this sleeping bag will give us. Now to go high, you're gonna have a lot of volume. So what we're gonna do tonight is we're gonna start sealing this together to make a balloon out of it. This is an emergency blanket. What we're gonna do tonight is we're gonna take some special poly tape. I'm going with some extra wide. We're gonna bring the 2 seams together. We're gonna take the widest distance, 142 inches, make that a circumference of our balloon. So we're gonna bring that 142 inches around like this, and we're gonna tape it down the seam. Once this tape goes on there, you can't pull it apart. It's just really, really strong. In addition to taping it, what we're gonna do, we're gonna overlap this about 1 inch, and we're gonna tape the seam all the way down, and then we are going to turn it inside out. And where we've made that seam, we're gonna overlap it about 1 inch. We'll tape it on one side, but overlap it about 1 inch. And then we're gonna take some 3M 90. It's very super adhesive. And we're gonna raise that little flap up, and we're gonna put adhesive all the way down that edge. We'll have a little flap. We'll have 1.5 inch flap back here, very thin. We're gonna try to turn this inside out now. Let's see. Go down this splice. Thin. You can actually see through it. When you hold it up to the light, you can actually see see people through it. Hanging over a little bit on both sides. What we're gonna do, we're gonna overlap it. We're gonna overlap it about 1.5 inches. We'll have 1.5 inch flap back here. We're going to turn it inside out. What that's going to give us is turn it inside out. We're going to have a flap like this. All right, so what we're doing there is I'm showing you how we're trying to get a airtight seal and something that holds. There's tremendous pressure to pull this thing apart, and by the tape alone would hold it, but we're going redundant with everything. So we're adding the adhesive on the back side, the tape on the front side, and that's kind of where we are right now. Go ahead.
Do you think, could you just tape both sides? Would that be lighter?
Well, no, the 3 inch tape adds 2 grams. No, the 3 inch tape adds 3 grams per foot.
Oh, okay.
So that would be 6 grams per foot.
Yeah. Now
the adhesive adds about 0.2 grams per foot. It's a lot lighter, and man, it sticks too, man. So in our testing, and I've got several sheets together here, and we've been testing materials. You can't pull either one of them apart. The adhesive or the tape, either, is actually as strong or stronger than the actual Mylar itself. So. And it gets a good bond. So let me just fast forward through this a little bit further here. We're doing this for just safety. Oh, let's see. Here's a Mylar material. Let's see. There we go. It is as strong as a single piece of Mylar material. You cannot even pull it apart. So we probably didn't need the tape. But we're doing this for just safety. I don't want our seams going bad. Now, per foot. So again, 6 times. Let me get a little out of this thing. Okay, here we go. So far looking good. Yep. All right, I think I've got a good covering. Gonna check it out, cameraman, and make sure I'm putting saw all the way up. I think we've got it good there. So we're gonna let this get sticky. We're gonna probably give this about maybe 45 seconds or 1 minute. And then we're gonna fold this over, and then it's gonna stick. And it's gonna stick, and it's not gonna come apart. We can get it. Pretty good. Pretty good. All right. Okay. Now the critical part, the more difficult part. We're trying to seal the end, and we have corners here that are possible. It's sealed across there with adhesive. We're going to take again about 1.5 inches, and we're going to roll this top over, and then we're going to adhesive the key points here. We're going to do the best we can here. Down and hope we get it. All right, so I think we've got a very good. That's going to be ends, and also this is very delicate. It wrinkles very easily, and when we start folding this over and sticking it, man, once it touches, you're not going to pull it apart. So that's going to be, we're going to do the best we can here. All right. Okay, we've filled this, turned this over. I've got adhesive on the two sides here. And it's getting really sticky. We got it all the way down, so we're going to start folding it down now and hope we get it. All right, so I think we've got a very good seal there. Now, the thing is, when you put two pieces of material together like this, and you put a seam down it, when you get pressure, it has a tendency to peel. It'll peel like this. If you do a butt splice like this with tape down it, it's real strong. But this has some weakness to it because the material's like this, and it fills up with gas like this. It's going to start peeling like this, and it will peel. So we're going to reinforce this. What we're going to do, we're going to fold the corners over, just in case there's a little leak in the corner there. We're going to fold the corner over, glue it down, and then after we get the corners there, we're going to take this top one more time, and we're going to fold it over about 1 inch, and we're going to glue it down. And then we're going to take our 3-inch tape, and we're going to seal that down. So our next step is going to be to you get maybe a little less here, but we'll see how it goes tomorrow. We're going to try to pressure test it tomorrow. All right, so that's kind of just a quick overview of how we're sealing this thing up. And once it's sealed up, we took it out, and of course we want to test it for leaks. If we have any leaks at all, the hydrogen is going to leak out and it's going to come down. We don't want that to happen. We're putting a lot of effort and time into this, and a lot of redundancy and everything. So we're really testing for leaks. Now, I've got it out in the shop, and I'm not going to take this up to 19 inches of water like I did the other material and explode it. We know that the pressure at altitude is going to be about, 4, 5, 6 inches of water. We know the material can withstand 19 inches of water lift. So I'm just pressurizing it to get it up to the, 6 inches or so, where it'll be pressurized as it's flying. And that's mainly to check for leaks. None of our seams had any leaks at all that I could tell. I mean, it just solid. Also, the other parts, all the material seemed solid. I did have a little problem I kept having a leak at the very bottom where I have the filler hose put in. Let's see if we can see something here now. At the bottom, what I did, I put a filler hose in, and I crinkled the balloon around that filler hose. I wrapped it with a piece of rubber from like a rubber tire. I wrapped it, and then I put a hose clamp on it and tightened it down really tight to try to get a good seam right there. And I kept losing a little pressure, and I kept noticing that, you know, I've got a leak somewhere. I kept losing some pressure, and finally I took some soap and water and put it right there where the hose goes in, and I was seeing bubbles there. So I feel very confident that my leak is right there where I've got the hose coming in. Now again, that was just to test it for leaks and to make sure the integrity of the balloon and it all stays together. So once I feel confident that it's not leaking anywhere else, and it's under pressure right now, once I feel it's confident it's not really going to leak out, then we'll pull that tube out, we'll flatten it down, we'll get all the air out, and then on launch day we'll bring our hydrogen in, and we're going to, by the calculations here, the cubic feet we've got of the balloon and the weights of the material and everything, you can actually calculate how much lift to put in it and at what altitude it will fly. It appears that the indications are showing this is going to fly about 56,000 feet. That's where we want to be. I've been wanting to, for over a year now, fly at 55,000 feet. Nobody else is doing it. And we're going to, if we can make this work, I'd like to send this thing around the world and then we'll be successful. So even if we fly at 50,000, that's considerably higher than what we've been able to fly with the SBS balloons. So we'll pull the hose out, we'll get all the air out. Launch day, we'll come in there and we will put our tracker weight is going to be about 20 grams. It looks like to me if we use 17.2 grams of lift, so that'd be 37.2 grams of total lift. So what we'll do, we'll hook that to the scale and we'll put hydrogen in to where it's lifting 37.2 grams. And when it lifts 32.7 grams, we cut the hydrogen off. We will then, that little hole where we put the hydrogen in, we're going to roll that up, crinkle it up, tape it up, seal it up somehow. That's going to be our only point that we have to close up. And then we're going to tie our 20-gram tracker on it, and we're going to take it out there and lock it. And we'll have 17 grams of lift on it, and it ought to go up. Now, it's going to be exciting. It's going to be fun, but we're gonna see how it goes. All right, Allan, what did we do wrong?
I think it's all good. I mean, I was just wondering if you could make, if you think about the Mylar balloons that you get at the party store where it comes down to a little bit of a nipple where they fill it.
Yep.
That might be something easier to seal. So I guess that's what you're probably going to do.
Yeah. In fact, I've got some of those 3-foot Mylars, the silver Mylars. It's like, in fact, that's what we flew at the East Tennessee Hamfest last week. And a 36-inch balloon isn't going to get you much altitude, and particularly with we used helium. We only attained 18,400 feet altitude with it, and it went up into Canada somewhere that Saturday or Sunday. It made it past. It went over your house, and it went on up into Canada.
Did you ever pick it up after that?
No, I think we lost it. It was starting to be storms up there, and at 18,000 feet, that's a dangerous place to be when you're having storms there. See, the nice thing about trying to get up in the 50s, 55,000, you got a much better chance of going over the top of those storms. So that's the main reason we're trying to do this. Now, if you get too high, if we get 65,000 or something, the wind is not, the wind's only moving about 4 knots up there, just a few miles an hour. And it could take it, I mean, if it goes around the world, it might take it 4 months to go around the world. So, you know, the jet streams are down a little bit lower. They're down in the 40s, a little bit in the 50, you know, high 30s, you know, in that area there. So that's kind of what we've got going there.
I'm gonna have to run. I gotta go walk the dog.
Okay.
Good to see you tonight. Hopefully you enjoyed the segment, and we should see you next week.
Well, very good. We will see you next week.
All right.
All
Sounds
right.
good.
All right. Goodbye.
If you worked out the calculations on absolute max height you can give out of this?
Well, Glenn, yeah, there's a lot of calculations. A lot. I don't know if you can see some of the. You probably can't see much of this where I've been scribbling on paper. Whoop, wrong one. You probably can't see much here, but I have run so many numbers with the volumes and weights and air and lift. I mean, you know, you change the free lift, that changes the internal pressure. Because when this thing, the way one of our pico balloons work is when they reach super pressure, that's where they float. So in other words, this bag is going to be almost empty as it starts going up. And as it goes up higher and higher, the hydrogen gas will expand. And at a certain point, that gas is going to expand so much that that balloon is tight. It is stretched out. It won't stretch anymore. Now, you got two options there. It can burst, and that's where it's going to float. It won't go any higher. Once that gas stretches out and it can't stretch out anymore, that balloon will not go any higher. So you got two options at that point. It pops and comes down, or it floats at that specific altitude. And so that's why we had to have this stronger material. Now, the other thing, if you look at it, let me look at the shape of this thing. Oh, let's see. You can see this is not a round sphere. This is not anything. You know, we take a rough estimate. Well, not an estimate. We take measurements of the bag. It's so many inches in circumference and it's so many inches tall. That supposedly makes a cylinder, and you can calculate the volume. But you can see it doesn't blow up like a cylinder. It kind of blows up like a pillow, kind of flat. So it's really difficult to know exactly how many cubic feet of volume we have there. So we've trimmed off some here. Worst case, and we've got best case, worst case, and we think that is going to give us 96,240 cubic inches of volume, and if you convert that to cubic meters, that's 1.577 cubic meters. Now an SBS balloon is 0.5 cubic meters. This is now 1.5 cubic meters. I took some other measurements after it was blown up today, and let's say it only turns out to be 1.4 cubic meters. At 1.4 cubic meters, and at a reasonable lift in here, I'm seeing 53,800 feet. So I think it's going to fly in the 50s. It's kind of an unknown. I think we'll exceed 50 with it. We don't know. We don't know where it's going to be, but I think it's going to be over 50, and that's exactly where we want to be. So we probably, hopefully, we'll launch this maybe about next Tuesday morning, possibly. Let's see. We may try to fly the sleeping bag. The problem with the sleeping bag is, I think the sleeping bag is going to fly 44,000. And that's where we fly the SBS balloon, and it's no fun if you can't go higher. So, but we'll probably do it just to prove it can be done there. Hey, let's open the phone lines for people, and let's see if anybody wants to join us tonight. So I'm going to start the phone lines up here. Let's see, where's my ticker? The phone lines, the new phone lines. There we go. All right. So if you're out there, give us a call. You dial the 716-427-1083, and then you enter the code 407051 #, and you'll be on the show with us. We'd love to hear from you. You know what? Let's also do this, Glenn. I guess I can. Can you easily put the link in the chat room?
I think so.
If you can't do it, I can pull up my mail and I can post it. We'll also post a link
Here we
here.
go. I
You
got
it? Okay. All right. So Glenn's going to post the link here in the chat room, and this will get you on Zoom, and you can join us on Zoom here.
Figure out which of these 30 million windows.
Yeah, let's see.
There we go.
All right, there's a links guy. Hey, everybody, just click on that link and you can join our show there and come right on the show with us. We'd love to have you tonight. And we'll talk about anything you want to about ham radio. And it doesn't have to be about balloons. You know, we've got one guy in our chat room here. Every time we say the word balloon, he leaves us, which is okay. Not everybody wants to hear about balloons, you know. But we have a lot of people that do want to hear about it. And this is ham radio, and we're going to try to do something in ham radio that nobody's done before. All right, come on, guys. Let's see. Oh, I think we got Carlos there. Let's see, we got Carlos there. Let me get the phone going. Trying to get the phone going. Host meeting. Hello, Carlos. How you doing?
Fine, thank you. Hello.
Good to have you on here tonight.
Glad to be able to connect tonight.
Yeah.
I was on a trip, on a business trip last week.
Yeah.
I went to the countryside to do a job on the countryside. And at the last moment I decided to take an HF transceiver.
Yeah.
So that I could test the receiving on the countryside with very little noise.
Right. How did it turn out?
You are the only participant in the conference.
Let me turn it down.
I'm the only participant in the conference.
Yeah. Yeah. So how did your interference test?
Very interesting. I didn't have much time to play around, but and I couldn't deploy. I wanted to hang a long dipole, but I couldn't manage to do it because I didn't have the right tools for the job. But managed to hang a very small dipole, like 5 feet per side, maybe 5 feet per side, a very small one, and with a very simple tuner that I had lying around. I could barely tune it to 40-meter band, and managed to make a couple of contacts with south of Chile and there. So it was a really good experience there. To be better prepared for another trip in the future.
Yeah. So do you still have all that interference at home?
Yeah.
Oh boy.
Yes, it's difficult to come about.
Yeah.
I don't know.
Yeah. I'm reading the chat room here. Just checking the chat room out. Didn't have time to check it there. Man, if I did that in my kitchen, my wife would have my head. My Kathy helped me to do that. She's very supportive of the hobby here. She tells
Yeah,
me
what he doesn't mention is that it cost him a complete kitchen remodeling last year.
more about half the house remodeling, not just the kitchen. But hey, every day she tells me I need to go out and buy a new ham radio every day. Go buy you a new ham radio. Well,
That's an excuse. So
I can't find anything I want. I have been looking for months now to find some new radio or something. I can't find anything I want.
I can help.
Yeah, okay.
I've got several on my list.
All right. Larry asked, will the balloon work as a half? Will it work as half of the dipole? Not really. The half the 20-meter dipole is 17 feet, and this balloon is going to be about 6 feet tall. So, it might work on maybe 10 meters or something. I'm not sure how to fasten the wire to the balloon though, without damaging the balloon. It's very thin, very thin.
Is it conductive?
Well, I don't know. I don't think it is. It is silver. I think it would be radar reflective. Yeah.
And it doesn't have to be silver color for it to be radar reflective.
Yeah, that's true. That's true.
I would think that the balloon is conductive. So you can just wrap the coils around it a little bit or something.
I don't know.
A couple of loops.
You know what? We're going to test that right now. I've got a piece of foil here. I think I got a piece of foil here. Maybe I don't. Well, all right. We're not going to test that right now. I don't have any. I don't have any foil back here. I was going to get a multimeter over here and test it. They're asking about radar over North Korea or China. I guess it's possible. Of course, we do not transmit. We don't transmit over North Korea. It's okay to transmit over China, but we don't transmit over North Korea. I don't think they'd spend $500,000 to shoot it down. They'd probably just let it go. Glenn, it does have the little Arduino-based processor on there. I'm sure you could help me program it where I could make it when it gets in that geo fencing zone. When it gets over Korea, we could drop some pamphlets or something.
Yeah, I'm sure we could do that. And at the same time, we can test our World War III preparations.
Yeah. Okay, let's see. Yeah, Charlie, that balloon is so big I can't submerge it in water. It's too big, man. It's like 6 foot, man. I'd have to find a swimming pool, and then I don't think I'd be able to get it under the water.
Yes, I was thinking when I
thought about maybe I can fill it with water and then pour it back out, but that would also be a lot of water,
that would be several hundred pounds worth.
Yeah,
of water.
that would be a lot of water, and I'm not sure. I don't think you would hold that pressure. Look, I got. Oh man, I don't know if you can see this. Let's see. Look here, I got adhesive. I got adhesive on me. That's not. Oh man! Ow! Sorry about that.
Are you sure that didn't come out of your nose?
I was going to say it looked like that for sure, but no, the stuff that comes out of my nose don't stick that hard, man.
Okay.
It don't stick like that. Boy, I'm about to pull the skin off of me right there. Well, Colin says, if it's in cubic meters, would it be easier to measure in millimeters instead of inches? Not really. All my all my tape measures are in inches, so it wouldn't be easier. I do have a few that might have millimeters. Hey, you know, when I am working on small projects and laying out like a chassis or a little front panel, I will use millimeters or centimeters because it's so easy, you know, to find the center, you know, and to do things. So, you know, there's a good purpose for metric. But
Yeah,
I just take it in inches, and then I just convert to meters. There are so many calculators on the internet now that you just put in the inches, and 2 cubic inches. It tells you the cubic meters. It's just that simple.
Yeah.
Google itself, from long time ago, it does that. You on the search bar of Google, you write like, for example, 25 cubic feet to cubic centimeter, and
You don't need to search for a pool. I got one. Bring it over. Of
Yeah. Let's see.
course, it's getting a little too cold to swim in right now.
Yeah.
But you know, I've got to think there's got to be a way that you can extract the gas out of a full balloon and measure that gas as you're releasing it or
Well,
vacuuming it
I
out.
always wondered that, but when you put that gas back in something, you got to make sure it's at the same compressed level somehow.
I was just going to say, all you want to do is measure what comes out.
But and then again, I think it makes a difference with the gas. If I put hydrogen in and I took the hydrogen out, the hydrogen is going to keep trying to expand.
But you want to measure weight or you want to measure a volume?
Well,
That would be
I
the
can
other
measure.
way.
I can measure. Measurements of the balloon and the tracker, of the weight of the balloon, the tracker, the line, the antenna, all that plays into the formula. But I do need to know the volume, and we've been pretty close on volumes on all of our other flights. This one may be a little different because of the funny shape that we're going to be in here. But
Here's another way.
yeah.
You know the lifting capability of the hydrogen. Just measure the lift of the entire thing when it's near bursting, and then you subtract the weight of it, and that will give you the lift, and you should be able to reverse back and figure out how much helium you got in it.
So you're telling me to fill it up to bursting, and just right under bursting with hydrogen? How do I know where to stop?
Well,
18 inches, 17 and a half.
Yeah. You know, I mean,
pick a point and say this is point A, and get a measurement, and then take it higher and get another measurement, and then take it higher. And when it bursts, the last measurement you got is the one you'll go with, and that will tell you the maximum amount of lift, and that will tell you how much hydrogen you had to have gotten into it to get that lift. So you can reverse that formula and figure out how much hydrogen you got in to get.
yeah. You know, I've looked into that. The little devices made to measure the hydrogen and all that. You know, it's only like $25,000. You can't just measure it with I don't know.
Well, for the lift, you can just measure it with your scale.
Well, I could measure lift.
That's the goal.
Not lift.
But it's good. But it's going to keep
weight.
expanding. I mean, gee.
No, you can weight the container, the hydrogen container, and see the difference between when you started and when you finish.
Yeah. Well, Tom, you're always calculating these to have X amount of grams of lift.
Yep.
So you've got that formula because that tells you how much hydrogen you must put in. Well, let's reverse that formula and say, how much lift do I have? And then say, oh, okay, I've got 35 grams of lift. How much hydrogen do I need to have gotten to that 35 grams? Then I'll tell you how much hydrogen you got in. Just reverse the formula.
Yeah, the spreadsheet I have
Well,
The spreadsheet I have does all those calculations, and you put it.
Find the formula. Get Bill to find you the formula and
Well,
reverse it.
But I think that formula is built into that spreadsheet because one of the variables on the spreadsheet is cubic feet of the balloon. Cubic feet of the balloon, weight of the balloon, weight of the tracker, the amount of gas you put in. So, yeah, okay. Well, it's going to take somebody better than me.
I would say get Bill. I guarantee you Bill's got that formula and he probably has already worked it out.
All right. Well, as soon as his foot heals, we'll try to get Bill in here. Let's see.
Yeah, they're saying that link I put in didn't work.
The link.
But Carlos got in,
Yeah.
so
Who said it didn't work?
Bill.
Bill always says it doesn't work.
In, so the link worked.
Yeah.
Bill always says it doesn't work when he tries it. I don't know why. But everybody else uses the same link and gets in, you know.
Yeah. And that 5/8 plus 7/30 seconds, let's see, that's going to be 27:30 seconds.
Then they say metric is complicated.
Well, actually, I'm trying to think where I saw this. Oh, a burger chain decided to sell third-pound burgers when McDonald's came out with their quarter-pound burgers, and they wouldn't sell because people thought a third of a pound was less than a quarter of a pound.
There you are.
Mark is saying I can vacuum it out and I can vacuum it out, put it back in a cylinder, and I can measure the weight change.
Yeah.
Maybe, but
No, but you measure the weight change from the you have the hydrogen in a container, right?
yeah, but there's a difference here because whether it's compressed, is it compressed at so many
Pressure.
pounds per square inch or something, or is it more? I mean, it depends on what you compress it to.
Yeah, but
you're
drawing it from a sealed vessel, so you're not going to have something coming in. It's going to expand, yes, but it's not going to add external
Mass.
gases and mass to it.
External
All right.
mass. So you can measure the weight of the gas you put into the balloon. It's straightforward. You put a scale underneath the container, like those for you have. We don't have it here, but you have those for preparing the mail packages, which go up to 200 kilos, I think, something like that. And you put the display beside the camera, and you can film until it bursts, and there you have the pressure where it bursted and the weight of the gas you put in.
Yeah, okay. Glenn, next time you're out, just come on by and I'll let you measure it.
Uh-huh. Oh, I was just thinking, releasing that much hydrogen into an enclosed space.
Yeah, all of a sudden.
Here's the deal.
I don't think you have enough protective gear.
Here's the deal, guys. I'm sure that what we're all saying is doable. But I think it's going to take some precision equipment that will measure
I'm going
that.
to bet that Bill has a formula that you can take it directly from the lift. And the lift is nothing more than weight of the balloon plus the gas inside giving you your lift like you calculate it normally. And you just reverse that formula, and I will bet you dollars to donuts that Bill has that formula.
Okay, so if I have a cylinder that weighs 75 pounds and I pump the gas back out of my balloon into it, you think I'm going to see a difference in weight?
Not at 75 pounds, but I'm talking about lift with a Mylar object and calculating how much gas you already calculate with your spreadsheet now how much gas you have to put in to get 17 grams of lift.
Well, the interesting thing is the spreadsheet gets me in a ballpark, I may be off some on the
I'm gonna bet
cubic
I'm
meters,
going to bet
but
there's a real formula
but
that somebody uses to
but I have what I need because I can see I can measure the lift, and that's what I need. That's most important for me right now.
But I'm going to guarantee you there is some scientific formula that you can actually, formulas are made to be reversed. So all you have to do is say, I've got X amount of lift. How much gas did I need to put in to get this lift?
Well,
How much gas do you put normally into one balloon? How many grams, for example?
Well,
It's
cubic feet.
I don't. I put cubic meters in. And
Yeah,
for
right,
instance, on this balloon right here, it looks like it has a capacity of about 1.5 cubic meters. And I'm going to put in 0.19 cubic meters. And that will give me 17 grams of lift. So it's just a bubble in the balloon. That's all it is. It's not full. It's just a bubble.
Yeah.
It's just a bubble, and
I mean, there's your formula right there. 1.5 cubic meters equals how much lift?
what was that? 1 point what?
You said you put like 1.5 cubic meters in?
1.9. Yeah.
1.9 cubic meters equals how much lift according to your formula?
Well, it also depends on the cubic volume of the balloon. That's a variable.
No. Ignore. You're not concerned with the cubic volume. You're concerned with lift.
No, I am because if I don't have that if that 0.19 grams is not going into 1.5, let's say it goes into 1.3 cubic meters, then I'm going to have a totally different lift.
That's correct. But your spreadsheet gives you that. You know that 1.9 cubic meters is what you need for your 55,000 feet. How much lift minus the weight of the balloon does it give you?
All right. Well,
Then you can play with that formula. Put it on a piece of paper. Write it out, and I will bet you will see exactly what I'm saying.
see, if I use 11 grams of lift with the same size balloon, for 11 grams of lift, I'll get 56,036 feet high.
Yeah.
With an internal pressure of 0.069. That's an internal pressure. If I go 17 grams free lift, I'll fly about 100 feet lower.
You're already dancing around.
55,971. My internal pressure is going to be 0.1. 0.1 is about 2.77 inches of water.
Yeah. See, you're already dancing around the formula that I've been saying.
All right, we're going to have to change it. We're going to have to change the subject. We'll argue this thing all night, man. We'll argue this all night.
I guarantee you, I put it out on paper and you look at that and go, oh.
We'll just have to, let's see what's going on. Okay, nobody's on the phone. I got the phone lines open. Let's see who we got on. Zoom here. We got Bill Turner. Hey, Bill, how you doing tonight?
Oh, sound better if I unmute.
Yeah, there you
are. Doing well. We've had some solar activity over the last day or so, and the bands have been even worse than they were over the last weekend. But I think that's going to fade away here over the next couple of days.
Well, I'm seeing reports that the bands are starting to open up, 10 meters and everything. So I think things are getting better, right?
Yeah, we're starting to get some more some higher solar flux numbers, but this particular the 11th and 12th of this month we've had a coronal mass ejection and a solar storm that has hit Earth, and that has not done any favors for propagation. but I think that will fade away over the next few days.
Yeah. Well, I'm anxious for the bands to start getting better. There's been, over my lifetime of ham radio, there's been some really, really good years. There's been some really, really bad years, and I'm ready for it to be good again.
Yeah, it seems like every time I get a good station put together, it's in the down years, and I really can't use it.
Oh, let's
This
see.
time around, it'd be the other way.
Well, that's where FT8 and some of these digital modes come in handy when things go bad. The digital modes seem to handle those conditions better than trying to do it with CW or sideband.
Yeah.
Yeah. Just reminded me, talking about digital modes, there is a new kit from QRP Labs that just came out, which is a transceiver for digital modes. You know that Hans Summers from QRP Labs has this assortment of very, very interesting kits and with very good prices. And I've just ordered one to try it out. It has a couple of interesting features, like it has a high-end sound card inside, which is a 24-bit sound card, and the power amplifier, which is I think is just about 5 watt or something like that. It's designed for digital modes. I have to read a little bit about it, but it's as it's only digital mode transceiver, it's designed around being digital and not for a single side one. So let's see, when I get it here and build it up, I'll let you know about it. I threw in the chat a calculator I saw just now for calculating mass of gases and things. Maybe it's useful for something of the value.
All right, thank you. And let's see if Bill got in this time. Bill, are you there, Bill?
No, he's not here yet. There.
Bill?
There he is. He's coming.
All right, Bill. We're going to find out what's wrong, why Bill never works the first time he tries it. He always, has a problem. Bill, you there?
He's muted.
Earth to Bill. Bill.
He gave us the 1 minute. He's muted, and he's obviously talking to someone else.
Oh, okay.
So he's working a pile up on us.
Okay.
Good evening. Sorry for the inconvenience here.
All right.
I have to explain something here. I use the Zoom client because I do remote testing. Okay.
Yeah.
And to try and put in the meeting code that you got and that password, and it's coming up.
You don't need it. You don't need password or nothing. You just click on the link.
Oh, I clicked on it, but my since you're using Zoom, my Zoom thing comes up, okay, and it's asking me for a password, so I have to go back and figure out what Glenn sent me and stick it in there. And it said that the meeting was.
Your Zoom is doing something different.
See, I bet you, we got 4 or 5 guys on here right now. I bet you nobody that came in tonight had to use a password except you.
Do they have Zoom on their computers though?
Yes, I have the Zoom.
Yeah, I have a Zoom client on my computer, but I'm using the
just the link
list that was published by Tom. I just clicked on that link and here I am.
There's a checkbox when Zoom starts. There's a checkbox or a little dialog box that comes up and says, "Do you want to continue?" And you just click yes, and it ignores the client.
Okay.
Well, anyway,
right, so I'm here now.
Anyway,
sorry for the inconvenience.
Hey, anyway, you're here, man. You made it. That's what's important. You made it, man.
Yeah, and Rodan ran away on me. I was hoping to say hello to her before she ran away.
Yeah, yeah.
Oh, she's gotten a little full of herself here recently. They're both in this, we want to go to a cat show, and they're wondering why I'm not taking them anywhere. See, because to them, hotels are like Disneyland. And the shows are kind of like, who cares about that? We want to go to Disneyland, and they haven't been to Disneyland in 2 years. And, you know, they're getting a little pissy about it.
It's called cabin fever there, Glenn.
That's really what it is. Yeah, they miss, because when I take them to a show, for example, we get in on the day before the show, and they are literally all night long jumping from bed to bed in the hotel room and just playing all night long. So when the showtime comes up, they're like, oh, God, it's too early. We don't need to go to the show. Can we just stay here? And they sleep half the day.
All right, let's see here. Hey guys, well, we got a minute here. I get this phone call. Let me put this on here. Let's see if I can do this.
You're not going to give us this phone call about your vehicle's extended warranty, are you?
No, I get this phone call from Microsoft Tech Support.
Oh, yeah, I got that one,
Man,
too.
I got this phone call from Microsoft Tech Support, and I don't know, man, they scared me, man. Let's see. Let's see.
This is Max Watson from the Windows Technical Department.
Let me
About the computer.
stop that phone line,
All right.
wherever it
We
is.
have been receiving some error and warning reports from your computer. And as per the reports indicating that your computer
Let's see. Close window.
unwanted junk and malicious files, which are
Okay.
and damaging the software part of your computer
Close.
day by day, alright?
Oh, really? Wow. Now, you know, this happened to me about. Okay, let me start it over. Here's my call. Wasn't sure how to handle it. All right, hello, are you there?
Yes, I'm here.
Yeah, and who's calling?
This is Max Watson from the Windows Technical Department. Alright?
Oh,
About the computer.
okay.
Alright?
I got to get the phone line turned off. Hang on. What is going on here?
And as per the reports indicating that your computer has been downloaded some unwanted junk and malicious files, which are hampering
Well, shucks.
and damaging the software part of your computer day by day, alright?
Oh, really? Wow. You know, this happened to me about 6 months ago, and I paid somebody $500 to fix it.
Okay.
Is it doing it again?
What?
Okay.
Yeah, I paid a lot of money
All
to
right,
have this
here we
fixed.
go.
Is it-
Pay someone?
I did.
Let's see. Here we go.
Yes, I'm here.
Yeah, and who's calling?
This is Max Watson from the Windows Technical Department. Alright?
Oh,
Talking about the computer.
okay.
Alright? So actually we have been receiving some error and warning reports from your computer. And as per the reports indicating that your computer has been downloaded some unwanted junk and malicious files, which are hampering and damaging the software part of your computer day by day, alright?
Oh, really? Wow. You know, this happened to me about 6 months ago, and I paid somebody $500 to fix it. Is it doing it again?
What?
Yeah, I paid a lot of money to have this fixed. Is it?
You pay someone?
I did.
Someone?
I did.
Oh. Let me check it out, sir. Are you in front of your computer right now?
Let me walk to it. I'm near it. Just a minute, please.
Sorry?
Hey, you're with Microsoft?
No, sir. Microsoft never used to call anybody.
Oh,
Microsoft is just a manufacturer of Windows operating system, and we are calling you from Windows Service Center, who provides support and services to all Windows users.
oh, okay. Windows Service Center. Okay.
Yes. And is your computer on right now?
Yeah. Yeah. Okay. I'm at my computer.
Okay. And Now, what do you see on your computer screen?
Well, it's just my desktop.
All right. Just hold for a moment, sir. I just transfer this call to one of my technicians, all right?
Okay.
And you pay $500, right?
Well, yeah, I did. Last, I don't know, 5 or 6 months ago.
Okay, let me check it out. Just be on hold, sir.
Hello?
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 Yeah, hello, sir. This is Steve Watson. I'm the senior technician of Windows Service Center. How are you doing?
Hey, Steve. Yeah, I don't think I didn't pay you guys. I paid a local company here, I think, when I had a problem before.
Okay. So, can you just tell me, like, is the computer turned on?
Yeah, it is. Uh-huh.
Okay, let me go and show you the problems. Let me check that for, like, whom did you make the payment? And we need to go and find it out, like, what would be the solution to fix the problems for the permanent basis. Right now, you are getting this call from Windows Technical Department. It is a service center who provides support and services on the Windows computer. Okay.
Yeah. So, Steve, let me ask you a question. I've got 4 computers here. Which one is it?
Okay, can you just tell me you're using a same internet connection on all the computers?
I guess.
Yeah. Yeah, so the problems which I'm talking about, sir, is getting entry on the computer through the internet. So all the 4 computers getting infected. So you need to just go ahead and turn on any one of the computers so that we can able to go and show you the problem.
Okay. All right. Now, the one I'm at right now, this one, I think this is a Linux. Do I have a problem with it?
No, there is no problem on a Linux. Matigada.
Okay. So I need to go to one of my other machines. Is that correct?
Yeah, which is Windows.
Oh, okay. All right. Hold on 1 second.
What do you see?
All right. I'm almost there. Almost there.
What do you see on your computer screen?
Okay. No, just a desktop.
All right. Do one thing. Look on your keyboard.
Uh-huh.
At the extreme left-hand side, bottom corner, you will be getting a CTRL key, the control key. Do you see that?
Yeah, I see that. Yes.
And just beside to the control key, do you see any 4 flag Windows logo key?
Yeah. Yeah, I do.
Press that 4 flag Windows key along with letter R as in Roger.
Okay. Okay. All right.
After that, what comes up?
I had a message box that popped up.
And just read me out.
You may read it to you?
Just read me out.
Okay. It says, I, Tom, find myself talking to a two-faced potbelly baboon that couldn't catch a cold if the wind was blowing. What's that mean?
Oh.
What's that mean?
So that means, and do one thing, sir, and just beside to that message box, do you see any?
Yeah, let me start over.
There, like,
Let me start over again. Okay, I hit escape. Okay, you may hit the Windows R. Is that right?
Yes.
Okay. This box came up again. It says, I, Tom, find myself talking to a two-faced potbelly baboon that couldn't catch a cold if the wind was blowing. I don't understand.
You not understand, right?
I don't understand that.
I can explain you, sir. Look at the very bottom of the screen, okay?
Yeah.
Look at the very bottom of the screen. Do you see someone, your mother, very badly?
No, it's mainly talking about you. You know, you guys call me every week, maybe 2 times or 3 times a week. The biggest scam thing I've ever heard. You know, why don't you get a life? Are you ready to hang up on me? All right. Well, I guess we got rid of him. Yep, we got rid of him. All right. So I don't know, man. I like to talk to these guys. I don't know if you guys heard it or not on the remotes here, but that was one of my weekly calls from Microsoft Support Center.
You have far more patience with them than I do.
I've got a goal set. I want to try to keep them on the phone for at least 1 hour. That'll probably at least save a couple of grandmas, from getting tricked,
What you need to do is Windows R and just keep mistyping what he wants you to type in the run box.
Yeah, man.
I've seen a couple of videos on the internet of people that really know what they're doing, that get into the computers of these guys, and I saw one that they even show their webcam to themselves on their monitor. So it's incredible.
They hack them back.
Yeah, exactly. So that's
cool.
really cool. Yeah.
Oh, man.
They're the ones I saw one that he deleted all the files of the scammer computer, and this guy in India, whatever, started crying and begging for him to give back all the files and everything. It was like really incredible. But I don't know. Yeah. So
Well, I talked to one of them one time, and I actually got him talking to me. And I asked him, why do you do this? And he says, there's no other job here. He said, this is the only job I can get. He said, it puts food in my family. He says, there's no other job. And we talked, and he said, where do you work? And he said, well, can you get me a job? You have offices, can you get me a job? So, I guess there's areas that this is an easy job to get, and there's probably no other jobs available.
yes, it's not their fault. It's the fault of the organization, of course.
Yeah, it's not their fault that they hacked you and ripped off your money.
Yeah. Somebody said we ought to add Echo Link here. We could probably do that pretty easily. That's a possibility. We could add Echo Link here. I'll try to get the website updated and get all the international phone numbers put on our website, because we do have local phone numbers in 65 countries out there. Hey, if you're listening out there on WBCQ International Shortwave, you've been listening to a discussion about ham radio and some other things. We're glad you're with us tonight. I would love to hear from you. Send us an email to tom@w5kub.com. We'd love to hear from you. Tell us where you are. And hit the subscribe button out there. For everybody that's watching the video, please hit the subscribe button. We'd love to have you subscribe. It helps us out there. We got just a few more minutes before our shortwave station our segment will turn off there. What time does the show play on WBCQ? That question came from AC5CM. That's actually my son, Chris,
You should know that guy.
down in Austin, Texas, down there where they're having trouble with the police department, or the police are having trouble with them or something. I don't know. But anyway, it starts on Thursday afternoon from 5 to 7 p.m., 5 to 7 p.m. Eastern, 4 to 6 p.m. Thursday Central Time on 7490. If you'd like to listen to this show, you can find it there on International Shortwave.
Well, good night, everybody. Enjoyed your program, and good luck with the balloon launch.
Well, thank you, and we're gonna keep on trying. I think I feel good about this launch. I think we can break that. I think we can break that glass ceiling right there. Right, 45,000 is the glass ceiling that everybody flies at big bucks, and I think we're gonna break it for $6.
Yeah, that's the cool part, is how cheap these balloons are, or this material is.
Yeah. All right. Well, I think we'll go ahead and probably sign off here too. Hey, Charlie, good to see you again tonight. And let's see, Bill, good to hear from you there. Don't forget, Nearfest this weekend.
Yeah, Nearfest is coming this weekend, October 15 and 16. Don't forget the masks and bring the hand sanitizer. We will be doing examinations for ham radio licenses on Saturday morning, 10 o'clock to noon. So if you're looking for a license and a place to go to take your license, hey, we'll be there.
I keep saying I need to get me one of those licenses one of these days.
Well, you have to have a license to be a ham radio operator?
Oh, yeah.
That's what he's saying. I've never heard this.
Yeah.
I just thought you picked up these numbers and made them sound good, and that's what you did.
All right, guys, good night. It's time to terminate the show and think about some popcorn and maybe some TV. And then I'll do a little editing here and get this on our podcast and on all the other places. See you next week.
Now, give my regards to Kathy. Good night.
I will. Good night, Bill. Good night, Charlie. All right. Good night to everybody in the chat room. We will see you guys.